Hello, welcome to the first lecture on measures of dispersion. Our learning outcome is to calculate the range, interquartile range and interpercentile range. Let's start with the range. This is the simplest one. Range is simply the difference between the highest value and the lowest value. Now move on to quartiles Q1, Q2 and Q3. And these correspond to particular data values in our data set. To find the quartiles, we split the data into 4 equal parts after we have put it in ascending order. 25% of the observations have a value of less than Q1. And Q1 is also called the lower quartile. 50% of the observations have a value less than Q2. This means that Q2 is the middle value when the data is put in ascending order. Now, does that sound familiar? That's right, Q2 is the median. Finally, Q3, 75% of the observations have a value less than Q3. And Q3 is called the upper quartile. Now, we do have to be careful. Different textbooks will calculate quartiles using different methods, so let's see how we will do it. First, we need to find the position of the quartiles. Q1 is in the n divided by 4 position, Q2 is in the n divided by 2 position, and Q3 is in the 3n divided by 4 position. And remember that n is the total number of observations. So Q1 is the quarter position, Q2 is the half position, and Q3 is the 3/4 position. So let's look at our methods for how to find Q1, Q2 and Q3. Now for discrete data, for Q1, if n over 4 is a whole number, find the midpoint of the corresponding term and the term above. When n divided by 4 is not a whole number, round the number up and pick the corresponding term. And similarly for Q2, we have already seen this method in the last lecture. When n over 2 is a whole number, i.e. when n is even, find the midpoint of the corresponding term and the term above. When n divided by 2 is not a whole number, i.e. when n is odd, then round the number up and pick the corresponding term. Finally, Q3, similarly again, if 3 times n divided by 4 is a whole number, find the midpoint of the corresponding term and the term above. And if 3 times n divided by 4 is not a whole number, round the number up and pick the corresponding term. Now that's for discrete data, but for continuous data or grouped data, we will need to use linear interpolation to find Q1, Q2 and Q3. And we have already done this for Q2, which is the median. Now the interquartile range is just the difference between the upper quartile, that's Q3, and the lower quartile, that's Q1. And we also notice that 50% of the data lies between the upper quartile and the lower quartile. So this means that 50% of the observations are within the interquartile range. Let's look at an example. Find the range and interquartile range of the following data. And here we have discrete data and just a list of numbers. So the first thing is to put them in ascending order. That's from lowest to highest. The range, remember, is the highest value minus the lowest value. The highest value here is 15. The lowest value here is 1. So the range is 15 minus 1, which is 14. Now let's do the interquartile range. So we need to find Q1 and Q3, since the interquartile range is Q3 minus Q1. Now to find the position of Q1, we must calculate n divided by 4, and to find the position of Q3, we must calculate 3n divided by 4. So let's do that. We count our numbers and we see we have 11 numbers. So n equals 11, which means that n divided by 4, 11 divided by 4 is 2.75, and 3n divided by 4 is 33 divided by 4, which is 8.25. We have discrete data, and neither n divided by 4 equaling 2.75 nor 3n divided by 4 equaling 8.25 are whole numbers. So that means in both cases we need to round up to the next whole number. So Q1 will be in the third position, rounding 2.75 up to 3, and Q3 will be in the ninth position, rounding 8.25 up to 9. So now we know the positions of Q1 and Q3. What we need to do now is to find the actual numbers, the actual data values. We can see that the third position is in fact the number 3, and the ninth position is in fact the number 10. So Q1 is 3 and Q3 is 10. Now the interquartile range, Q3 minus Q1, very easy, 10 minus 3 is 7. So the interquartile range is 7. So this means that 50% of the data is within 7 units of each other. In other words, 50% of the data, if we look between the difference between one number and another, for example, between 4 and 7, then we have a difference of 3. That's within 3 units. Between, say, 4 and 9, that's a difference of 5. That's within 7 units. Between 8 and 9 is 1. That's within 7 units. 50% of the data is within 7 units of each other. Let's look at a continuous example. The length of time to the nearest minute spent on the internet each evening by a group of students is shown in the table below. Calculate the interquartile range. So the first column, length of time spent on the internet, it is grouped. Second column, number of students, the frequency. And third column, the cumulative frequency, the running total. So, first of all, we need to find Q1. Now, we can see that n is 70. So n divided by 4, 70 divided by 4 is 17.5. Now, where is 17.5 in my cumulative frequency? Well, we can see that in the second row, we have the positions from 3 to 27. So that means 17.5 is in the second row, and therefore in the class of 32 to 33. Now, this is continuous data, so this means we do need to use linear interpolation. So let's set up our diagram. Using our class boundaries, now we can see that there are gaps between our data classes, so that means we need to use the midpoints. So for the class 32 to 33, we have lower boundary of 31.5 and upper boundary of 33.5. And we want to find Q1 somewhere in the middle. And for our cumulative frequency, lower boundary is 2 and upper boundary is 27, and the position we want is 17.5. So we've set up our diagram. We know that the ratios A divided by B must equal C divided by D. Let's put the numbers in, and now we just have to rearrange to end up with Q1 equals 32.74. You may wish to pause at this point to have a look at those numbers. But we will continue. Now we have Q1. Next, we need to find Q3. Exactly the same process, except this time we are doing 3 times n. divided by 4 to find the position. And we see that it is 52.5, but where is that in my cumulative frequency? It's in the third row between the 28th position and the 57th position, which means it is in the class of 34 to 36. Let's set up our diagram. And we have our class boundaries, 33.5, 36.5. Our cumulative frequency boundaries, 27 and 57. Now let's do the equation. A divided by B equals C divided by D. And here are the numbers. Again, perhaps you'd like to pause to take a careful look at the numbers. And we see that Q3 is 36.05. Now remember, we wanted to find the interquartile range, so we have Q3 minus Q1, 36.05 minus 32.74 is 3.31. So our interquartile range is 3.31. Let's move on to percentiles. Percentiles split the data into 100 parts. To calculate the xth percentile, we call it px, we must find the value of the x times n divided by 100th term. And as before, we will use the same rules as we did for the quartiles to decide which position to take and when to use interpolation. In other words, for discrete data, if xn over 100 is a whole number, then find the midpoint for the corresponding term and the next term. If xn divided by 100 is not a whole number, then round up to the next whole number. For continuous or group data, use linear interpolation. And the interpercentile range, very similar to interquartile range, except we choose the percentages. So from the n% to the m% interpercentile range is pm minus pn. And we notice that 25% to 75% interpercentile range is, of course, the interquartile range, because 25% corresponds to Q1 and 75% corresponds to Q3. Let's do an example. The heights in centimetres of 70 17-year-old boys were recorded in the table opposite. And we want to calculate the 90th percentile, the 10th percentile, and the 10th to 90th interpercentile range. So let's do the 90th percentile. But we notice that the data is grouped continuous data, so we will need to use interpolation, and cumulative frequency will also be useful. So let's add a column for cumulative frequency. And here it is. So we wish to calculate the 90th percentile, so that means that we need to do the 90 divided by 100 times n. Well, n is 70, our total number of pieces of data. And 90 divided by 100 times 70 is 63. So we want the 63rd term. Where is that? Well, the 63rd term is in the fourth row. It's between the 58th and the 66th position. And that corresponds to the class 180 to 190. We now need to do our linear interpolation and set up our diagram. Now, in this case, there are no gaps between our data values, so our data boundaries just match the classes. So we have data boundaries, lower boundary 180, upper boundary 190. For our frequency, we have lower boundary 57 and upper boundary 66. Now we do our ratio, A over B equals C over D, substitute in the numbers, do the maths, and we have P90 equals 186.7 centimetres. Next part, find P10. Exactly the same process. We know that N is 70. We're interested in P10, so we need to do 10 over 100 times 70, which gives us the 7th term. But where is that? It's in the second row between the 5th and the 25th position, and that corresponds to the class of 160 to 170. Let's do the interpolation, set up our diagram, the data boundaries 160 to 170, and the frequency values we have 4 to 25. Now A over B equals C over D. Rearrange to find P10 equals 161.4 centimetres. And finally, we wanted the interpercentile range from 10% to 90%. Well, we know that P90 was 186.7. That's P90. P10, we've just found 161.4. Find the difference, and we get an interpercentile range of 25.3 centimetres. So this means that 80% of the data, that's 80% between 10% and 90%, 80% of the data lies within 25.3 centimetres of each other. So we've seen some examples. Now have a go at the question yourself.